Alright, this is a little demo on how to make polyphonic synths in Max MSP. So you've probably already realised when you're using any of the oscillator objects when we've been building basic synths, the oscillators are not polyphonic. Each oscillator can only generate one waveform at a time, meaning it can only do one pitch. And that's exactly the same as in an analog synth. So to make analog synths be able to play multiple notes at the same time, like chords, they had to have different voices built, which meant for each note that you had playing, it would have to have its own oscillator, often its own envelope and VCA, and sometimes its own filter as well. So like the Juno, things like that, they all have that. Poly is a little bit like that. What Poly does, and here we have it in our patch here, it encapsulates a circuit. You build your own oscillator voice or synth voice, and you put it inside of a poly. And what the poly does is duplicates your circuit as many times as you need voices. So I've got mine set to 4, so that's got 4 voices. And when I play notes, so C, we get all 4 sounds playing at the same time, all 4 pitches. So there's a great primer. I recommend looking at this YouTube tutorial from Cycling 74 and also reading the chapter 21. That's the polyphonic tutorial from Cycling 74 on YouTube, and that is the chapter 21 about using the poly object. Worth reading those first so you know what we're talking about, and then this tutorial should lead on from that. So in the YouTube video they take you through building this synth, this poly synth, and if I go inside the poly object, that's the circuit that you will end up with if you follow the tutorial. It has a sawtooth oscillator, there it is, which is controlled by MIDI notes, and we can see the MIDI notes in this patch, in the kind of master patch. We bring it from note in, pack the pitch and velocity together into a list, and then prepend that list with the word MIDI note. Then that gets input into poly. So once it goes into poly, here we are on the inside, and it goes in, that just swaps the list around. So it makes pitch come out of that one and velocity come out of that one, so it swaps their order around. The reason for that is that we want the velocity to be done first. So the pitch comes through, gets changed to a frequency using MIDI to frequency, M to F, and then it gets held in a float which just holds the number until the envelope triggers the next note, and then that will push the new frequency into the sawtooth to make the saw play the new frequency. The ADSR, that's the envelope generator. It's being controlled via velocity. This generator goes from 0 to 1. And because as you know, MIDI velocity goes from 0 to 127, what they do is divide it by 127, which gives you a value range of 0 to 1. It's important that you have the decimal point there, because that converts it to a floating point number rather than a full integer. So the ADSR then is velocity controlled, and it sends its output to this, which is a multiplier. We've used it before, signal multiplier. Your signal goes in the left, and then in the right hand input is the controller, and any range between 0 and 1 will create a volume control. If you send it 0, the volume would be off. Send it 1, the volume is full. Of course, you can use these as distortions, which I think we did in the first or second lesson, where you send it a value of more than 1, then it becomes a multiplier, and you can multiply it by however you want. 1,000 times if you want, and you'll get a pretty vicious sounding distortion. The other thing, as it goes through in that Cycling 74 tutorial, is this this object. That is the thing that manages the voice allocation for you. So whenever it receives a new MIDI note, it just kind of tells the system whether this voice is active or not. And what's useful is that when it's not active, it will turn the DSP off, meaning that you're not using up unnecessary processing power. So it turns the little patch off when it's not needing to be an oscillator. But when you hold down a note, it turns it on, and we get the saw out. Cool, so that's our voice. Now, where the Cycling 74 tutorial ends is with just this patch. What it doesn't do is show you how, for instance, to create some controls for our ADSR. So that's what I wanted to look at. I'm command clicking and I can't unlock this patch. Because it's inside the poly, we have to click the little pen, and that allows us to edit it, and then we can unlock it. So how would we usually control an ADSR? Well, usually we'd have some kind of user interface object. Let's use a live dial. The default setting for a live dial was kind of a MIDI range, 0 to 127. But let's go to the little prototypes. So you roll over and go to the yellow triangle, prototypes. Let's get time. So that now makes it a range in milliseconds. That's relevant for us because we know in an ADSR, attack is a value of time, decay is a value of time, sustain is not a value of time. If you remember, that's a level, it's a volume level, and then release is another time value. So let's plug them in. Copy, click. So usually you would have all your controls for your synth. Potentially that would work, but the problem is when you close this window, you can't actually see the controls. Really, what we want are the controls to be on the outside of the poly, not the inside. So we're not going to add our controls in here. Let's delete them. Instead, what we'll add are some connectors, so it allows us to connect these ones, the internal connections, to the outside of the patch. We've already got one as an example, it's just in. If we can just copy that. Click and drag. Instead of in 1, let's call it in 2. These are just all of our inputs. In 3, in 4, and finally in 5, because we need one for attack, decay, sustain, and release. So we've got our inputs. These are data inputs. They're kind of think of it as a MIDI data input. If you wanted for some reason to get audio into your poly, then what you would need is an audio version of these, and it's just in tilde. So as always, the tilde marks a audio or an MSP object. We don't need that at the moment anyway. So let's connect this. So that's going to go to attack, that's going to go to decay, that's going to go to sustain, and release. Okay, all good. Let's save our patch. Command save, and close it. It hasn't added them. You will find this often you need to unlock it if you've got an encapsulated patch and just kind of initialize it by, well, rename it. Just going to delete the E and then put the E back on. They've all come back. Great. So that's our inputs that we just created. So let's just move that out of the way. Let's get our live dials. Again, make it that one a time value. And actually that one, let's make it, let's just get the default one. And this time I'm going to change the values myself using the inspector. Scroll down, I'm going to change its name. So this is sustain, that's why this is the odd one out. The range is going to be 0 to 1. And it's a float. And unit, change the unit to a float. And steps, let's change that to 100. Just check it. Yeah, so that goes 0 to 1. All the others, let's rename them as well so they make sense. So instead of time in the short name, let's call it attack. Decay, decay. Sustain and release. Release. All right. Let's connect them up and see what happens. So attack goes to that one, decay goes to that one, sustain to that one, release to that one. Lock the patch. Let's try it out. Let's do something with a really long attack, 1 second attack time. And I'm going to play a note. Cool, we get a long attack, but then if I play another note, that's got an instant attack. So's that, so's that. Oh, and that one's got the slow attack. Now, that's normal. You may have noticed that there are 4 different notes there. So there's 1, 2, 3, and then the slow one. 4. 1, 2, 3, 4. So the attack is only having an effect on one of the 4 voices. Notice that this poly is a 4-voice poly. So how do we make these controls control all 4 of the voices, not just one of them? Well, we just need to attach a little message to this, these parameters. We can do it just using a message box. So type M, and it's called target. As soon as you start typing, it will come up with a hint. That's a poly attribute, and it's a way to target a voice number. This could be useful for some reason. You might want to be able to target particular voices in a synth and, don't know, change their tuning or control only certain filters or something like that. Maybe it's flexible. Maybe you have a use for it. But in our basic synth, if we're thinking about a typical Juno type synth, really it only has one set of envelope controls. It's just got one set of attack, decay, sustain, release, and they go to all of the voices. Now, to send these to all voices, we do target 0. Target 0 will send it to make it go to all voices. Otherwise, you can target voice 1, 2, 3, etc. So we're target 0. So target 0 and then a comma, space, and then that's where our value is going to be. So as always, to act as a placeholder for our value, we use a variable. So $1. And as you will know, if I get another message up here just to see what and plug into the right hand input, it will set this. Oh, actually that won't show it because we've got a list. Anyway, that variable is replaced with whatever our number is. So we need to put that in between there and there. It just goes in between. Let's delete these other cables for a sec. Neaten it up a little bit. A neat patch is a happy patch. Don't know if anyone actually says that, but anyway, keeping a patch neat, I've said before, it makes it easy on the eye, but also makes it so much easier to problem solve when you're not looking at a rat's nest of cables. So yeah, I always spend a bit of time lining everything up, making sure it's easy for your eyes to read the patch. And let's connect these up. Doink, doink, doink. Great. Now let's try it out. So lock the patch. Let's send slow attack, slow release, full sustain. Great. Great. Let's hold a chord down. Perfect. So we're getting exactly what we want. So these are now going to target 0, which is all of the voices within a poly. Poly is doing all the clever stuff for us. It's duplicating this patch and it's assigning incoming MIDI notes to each one of the voices in turn as it receives the notes. All we need to do is make sure our voice circuit works. Great. Let's do part 2 of this little tutorial then. So we've got our polysynth working. What you might notice when you listen to it it's pretty I don't know, a bit static sounding. Not the sound doesn't move very much. What I really love about old analog synths is the way that the parameters are constantly kind of changing slightly. There's a certain random fluctuation in the voltages within an analog synth, which I think gives them some kind of it makes them sound more alive somehow. Digital doesn't do it. Digital gives you a perfect representation of what you want. So if you want a little bit of randomness, you have to build it into your patch. So let's do that. Going to open up, let's not save that, open up patch 3. And we've got the same thing. At the moment, this is set to 16 voices. I also put a little low res filter on there as well. Let's just, initially, no, I'm playing keys on my keyboard, not getting any sound. It seems like the patch is dead, but it's not. It's just that when you open it up, these controls are all at their initial state, which is all the way to the left, fully counterclockwise. If we bring the sustain up, there we are. So the patch is not dead, it all works, it's just that that was initialized. You may want that to be full sustain as a default, in which case I think you can do that in a variable in here somewhere. So order, range, initial value, let's say initial value is 1 dot. I'll just save that and close it. Open it up again. Where are we? Synth patch 3. Great. So the initial value is now 1, and when I play my keys, I get an actual sound. Good. You might want to do that for your patches, just to have them as an initial state. To make sure it actually does something. Cool. Okay, next let's go into our voice. Actually, no, I'm just going to hold a chord down and have a listen to the difference now. Can you hear the kind of pitches beating against each other? We're getting a bit of, it almost sounds like chorus. Play C major triad. And it's most prevalent if I turn up the release to quite a long time and play the same note twice. Get a really nice sort of chorusing and beating of frequencies. That is because of our randomness. So let's have a look at how we did that. If I go into the synth, it's pretty much the same apart from this little section here. So what's going on? Well, we need some kind of a random value to make it deviate, to get that random fluctuation. There's a couple of different random number generators. We're using Drunk. The reason for that is because if I just unlock this patch and have a look at the help file, if Drunk will generate a number between a range that you set every time it receives a bang. So if I click bang, you can see it's generating numbers. Let's use the metro to automatically bang it every 100 milliseconds. And what it does is creates this kind of virtual drunken walk home from the pub. Imagine this is our pavement, and that's the left side of the pavement, that's the right side of the pavement. The beer enthusiast is walking along, and their path is pretty wobbly. They're veering from kind of side to side in a random way. Oh, they've just stumbled over to the right-hand side then. And they're kind of bimbling along on the right-hand side. Then at some point it will randomly probably move. There it is, starting to go back. Oh, back on the right, balancing on the edge of the pavement. That's starting to sort of wobble back towards the centre. Oh, there we go, back in the middle. And maybe it will go to the left. So it creates that random drunken walk. As you can imagine, that's brilliant for mimicking that sort of random fluctuation in voltages that you get in an analog synth, because often temperature changes and all sorts of different variables will have an effect on all the little components in a synth that make them kind of do that all the time. So Drunk is what we're going to use to give our synth a bit of randomness. There is a random number generator. If I just unlock this and choose, just replace, remember you can replace text random, and it will turn it to random instead. If we use the random object, it still generates random numbers between 0 and 128, but there's no relationship between the previous number. What we get is a very erratic bouncing around of random numbers. So that isn't really very realistic. It's not very natural sounding. It sounds, if you want, too random. So for something to seem a bit more random, it actually has to be less random. Just a weird thing about human perception. So the random number generator is not going to work for our fluctuation. We want Drunk. Drunk is better. Switch it to Drunk, and that's better. And that's a much more kind of smooth, slowly fluctuating, a more sort of analog-y looking waveform. Cool. Okay, that was a little bit about the number generator. Don't want to save that bit. So what's happening? Well, we have a metro that's sending a little pulse every 100 milliseconds. That just creates a new drunk number, random number. The Metro also has two attributes set. The first one is active, which just makes the Metro active, and the second one is auto start. Both of them are value 1, which means that it's active and it's started as soon as the patch loads. That just means we don't have to have a toggle box to actually manually start it. So that's triggering drunk every 100 milliseconds. Drunk is triggering a random number between 0 and 10, but it's going to start on 5 and randomly kind of wander around there. If we plug an integer in, we can watch that. Yeah, there we are. It's sort of randomly stumbling around, side to side. Nice. To make those numbers a bit smaller, I've multiplied them by 0.25. So if I get a float now, because we're in floating point, so we're getting smaller voltage, if you want to think of it as a voltage, from 0 to 2.5. Okay, well that could work, but the problem is, so that's going to add from 0 hertz, because remember this is going to go into the hertz input of the oscillator. So it's going to be added by this little adder. If we add 0 hertz to our incoming MIDI note, then it's not going to be any change. If you press A above middle C, it's still going to be 440 hertz. But then if we add a couple of hertz, like 2, it will be 2 hertz sharp. That's going to give us a detune, but all the weighting of the detuningness is going to be on the sort of sharp side of the right note of right pitch. Just means that our synth has the potential to always be a bit sharp, which isn't going to be very musical. What we want to do is find some kind of a balance. So what I've done is minus 2.5. What that means is we now get a range from minus 2.5 to plus 2.5. And it's wandering in the minuses at the moment. That should give us a more kind of balanced ratio, so it's not going to make our voice always be out of tune. Cool. And then actually I've just noticed the problem. That should actually be 0.5, I believe. Yeah. So it's going to be fed into the plus, the adder, to add it to our incoming frequency. But before that, it goes through this little object which just creates a ramp between each one of these. Notice here it's jumping in quite large steps. The line ramps it so it makes a smoother transition. Let's get a float in there, so put a F for float and let's just have a look at that. Now you can see it's like a smooth line between all the different values. It's going to sound better. Again, a bit more analog. So that gets added in to there and controls our sawtooth. And of course this is duplicated independently for as many voices as we have. So each one is going to have a different, each pitch or each note is going to have a different drunk running the pitch of the note. So they're all going to be slightly out of tune with each other. And that's where we get the nice kind of thick chorusing effect. And if we play a note, I mean, that's pretty big effect. It might be too much for you. I quite like it when it sounds a bit wonky and out of tune, but it's all about taste. Remember, doing a max patch, half of it is technical, but you're actually being creative. You know, you decide what your synth is going to sound like, how much randomness you create. So that's where the creative element comes in. Great, well hopefully that's a good introduction to the polysynth. There's loads of info in that tutorial, and also do this one because that really tells you a lot about it. Okay, nice. Cheers, bye.